So I'm back with a cached file. You will notice that the playback is much faster. So this will help a lot. And now before we continue, let me show you the flipbook again. And there will be two major differences to what we already did on our splash exercise. First of all, on this exercise, we have a much larger terrain, or in this case, a much larger area where the flip will be interacting. Another very important thing is that once the waves are moving outward, we do not want them to bounce back. So remember, by default, when we created our flip simulation, the container is acting as if it was a closed container. In this case, we will need to avoid these bouncing waves and make them continue with their velocity outwards. So those are two things that we will be taking into consideration. Let's start now creating our first flip simulation. First of all, I will turn off both the terrain and the building collisions. And as I mentioned before, this time we will be using the shelf tools to make the process faster. So if you take a look up here under the ocean tools, you will find several setups that will help you create these ocean simulations. In this case, we will be using a flat tank. Now, before you click on this button, there's a very important gotcha that you must take into consideration. If you have any DOP networks inside your scene, this tool will attempt to merge the flip simulation into that DOP network. And in this case, we do have several DOP simulations that I did for the volumes. So for example, if you go into the explosion node, you will find this DOP network of the explosion. So in this case, if we click here our flip tank, the flip simulation will try to be merged with one of these DOP networks. And you could see which one of these networks it will be merged with. If you take a look under this tab, you will see a list of all the solvers that you have in the scene and which one of them is currently active. In this case, it's the missile trail. So to avoid any confusion, let's create our own DOP network out here. Let's call this one DOP Ocean. And we need to make sure to make this network active. So again, let's go into our list and tick on the DOP Ocean. Okay, so that's the only thing we need to be aware of. Now we can go ahead and control click on the flat tank tool and then just press enter with your cursor on the viewports. So immediately you will see that a tank has been created. This is our new domain. Notice how by default we are directed to where the ocean surface was created. So this is a geometry node called flat tank initial. But if you go back to your object context, you will notice that several nodes were created. And here we have three of these nodes. First of all, the flat tank fluid. Then we have this flat tank initial and also the flat tank fluid interior. Now, if you take a look inside our DOP Ocean, you will notice that here we have the actual flip solver and our flip object. So let's go back to the object context and organize these files. I will press Ctrl B to maximize this window. And first of all, I will drag this flat tank initial here under my ocean sim backdrop. Then I will put beneath it the DOP network, and I will also change its color. Then we have the flat tank fluid. This will be the import of the actual particles. And we also have a flat tank fluid interior that is used with Mantra to render an interior volume. But in our case, we will completely ignore this geometry. So you can turn this one off. Okay, so I will again press Ctrl B to go back to my original layout. And I want to go through these nodes real quick to see what has been created for us. So first of all, inside the flat tank initial, we have the ocean source. And this is very important because this will be determining the size of the domain, its center, and also some very important attributes of this domain. First of all, the domain will be initialized to flat tank, and this is very important. Another very important aspect is that here under boundary layers, this create boundary layer option is on. And this is very important because this will keep the waves going even if they touch the edges of the domain, as opposed to what we've done where the waves were bouncing on these edges. So keep that in mind. We will come back and check on this later. Another very important thing that you need to be aware of is that by default, this flat tank setup is creating a narrow band domain. And what this means is that instead of filling the entire domain, particles will be created only at a certain level, thus the narrow band. So if you click here on the particles tab, you will notice that this narrow band option is on by default. This is very convenient in huge extents because if your ocean surface is very large, you will require a lot of processing and a lot of disk space to be able to cache that information. And the narrow band makes it easier both to calculate and to store. In the end, we won't be rendering the interior of the ocean. We will only be rendering the surface. So as you can see, this flat tank preset is very convenient and it will help us to start working very fast. That being said, I will change the size of the container. I will use 90 meters in X, 30 meters in Y, and 95 meters in Z. I will also change the center to 12.5 meters in X, 10 meters in Y, and 12.5 meters in Z. Okay, so let's go back to our object context, and this time let's dive into our DOP network. So the first thing that catches my attention is that we won't have a gravity by default, and this will be very important for the simulation. So first of all, let's create a gravity node. You can connect it just below the merge node. And now we can take a look at the flip solver parameters. First of all, I will go to the particle motion tab. And from here, we will need a couple of very important things. First of all, the vorticity must be on. So we will need the vorticity attribute to generate our white water. So make sure to turn this on. Another thing that you need to be aware of is that receding should be on by default. And this is important since we're creating a band outside or actually on the edges of these domains. Particles will be leaving the domain. And in this case, we need particles to be created to replace them. And thus the receding should be on. Of course, this has been handled with our flat tank preset, and this is why I mentioned that I think that Houdini uses a very robust set of tools for the flip simulations. Okay, so finally let's check the droplets. Notice how by default detect droplets is off. I usually like to turn this option on because maybe in the future I will like to control these tiny droplets that separate from the main body of the water. And now let's go and take a look to the volume motion tab. Let's just make sure that everything here is okay. So if we scroll down, you will notice that the box size and the box center are channel referenced to our ocean source. And this will be very important because you want both to be the exact same size. Okay, and finally, let's take a look at the flip object. Let's just make sure that the resolution is something reasonable. And as I have mentioned before, I usually start with a low resolution simulation. And as I progress, I can slowly increase the resolution once I start achieving my final look. Now, something that may catch your attention is that here we have the closed boundaries on. And you might think that this will make the waves bounce on the domain walls, but since we have created a boundary layer, if we go back to our flat tank initial and take a look at the ocean source, this boundary layer will prevent the bouncing from the waves. So at this point, I think we're ready to create a first test simulation. Just for you to be aware, this simulation will be output into this flat tank fluid geometry. So it will be imported into this .io node, and it will be visualized by default through this .import node. So just be aware that this will be the actual geometry that you will be rendering. Okay, so let's make sure that we're on frame 1 and press play just to see what's happening. Of course, we only have gravity and we only have our domain, so probably nothing interesting, but at least we're making sure that everything is working as expected.